Hi folks, Chuck Black here. We're doing 52 weeks of Python. This is week number 11. In this lesson, we're going to talk about the dangers of using string literals and having those sprinkled throughout your code and the things that you might do in order to mitigate that. You may consider this to be more, at least intermediate topic, maybe even advanced, and that may or may not be true, but this is something that you're going to want to be aware of if you're going to graduate from being a simple Python script writer to being someone who actually develops software. So my recommendation is to give it a listen. I'm sure you'll learn something. Okay, so we're going to be looking at this lesson that you can see over here. I have called this particular Python module anyway, enums, constants, etc. Basically, the idea is that we are going to look at the use of enums or constants or other stuff instead of using string literals, or they could be numeric literals as well in your code. Now, you may say, well, why should I be concerned about this? That seems like a first world problem or something like that, where it's really not that big a deal and I should just not worry about it so much. And in fact, in the code when I've done Quaka, in many cases, I haven't worried about it. But if you're going to go beyond a Python scriptwriter in order to become a real software developer of any reputation, you're going to want to understand the danger in just throwing around literals such as I'm doing right here. So let's look at this code. I'm not going to go at the top right now. This is the functional part that I actually do something in. Basically, I'm in a for loop here. I'm going through a range of, oh, look, there's a numeric literal. Of course, I don't really care about that number. I just chose that arbitrarily, but you don't want to have constants like that flying around, especially not literal constants of that nature in a real program. But let's look at this. I'm going for 20 different iterations through this loop. I'm going to create a device dictionary, and my device dictionary is going to have a bunch of stuff in it. It's going to have a name. It's going to have a vendor, which I'm going to do using this random choice function that is a part of Python. And then I'm going to go through, and depending on the vendor, I'm going to set the OS and the version. So you can see I have set the OS. If it's a Cisco device, these are Cisco OSs. I'm going to set the version. Now, the versions, technically, if I was doing this for real, would be appropriate for the particular type of OS that I'm using, but I don't really care that much about that right now. This isn't real world. I just want to create a bunch of devices in as simple a way as possible so that I can print them out, and then so that I can demonstrate some things to you. So this thing right here and this thing right here are what we call literals. They are items of data in your code that are representing something. And the situation that we have here is I'm setting this literal to Cisco or to Juniper or to Arista, and then I'm comparing it, and I've got to type in this same exact thing, Cisco, correctly. Now, in this situation, I can just eyeball it and see that, okay, it looks like I've done it right. I've got a pretty tiny program, so if I have a problem, then it's not going to be that big a deal. But there are a number of problems as you graduate from just doing trivial Python scripts into doing real software where you need to use something different. What are the problems that you could encounter? Well, one easy problem right here would be that I could just mistype it. And as you can see, I don't really know that I've mistyped it. I can look at it, of course, it's right there. But if it was hidden down here under Arista and the Cisco part was still okay, I might not look down there and I would think everything was okay. And if I were to run this, let's see what would happen. Okay, so I end up with an error. Certain devices, I'm having a problem. Now that's probably a better situation. A worse situation would be that it runs correctly, but I get the wrong data. But so here's the situation where I've typed it wrong. And that would be one particular instance. Let's make sure that I've made it back to the way it should be. Now, another thing that I might do, instead of just having a missing letter, I might have something typed, maybe you remember your aunt telling you that you need to capitalize whatever that is, some type of noun that is actually a name, and the first letter needs to be capitalized. So here I've capitalized Arista, and I don't have it capitalized there. And if I run this, you can see it's going to end up with the same problem that we had before. And so that's an issue. So one of the things that I could do is I could, on one or the other of these, in fact, I'm going to go like here, and you could say, well, I could just do this, and then I could say, use my string function dot lower. And if I were to do this, I'm just going to do it for this one for now, then that will resolve my issue. I could obviously do that up here and up there, but what if my error was over on the left-hand side? Then I would have to do dot lower, and dot lower up here. Now that's not really the issue because I'm under control of all of the different aspects of things that are going on right here. But what happens if this is a value that is passed to me, the device vendor name is passed to me? What would I do then? Well, I could always do lower as well, but there could be situations where what gets passed to me, actually one person thinks of it as one name and another person thinks of it as another name. And as your software grows, you are no longer in charge of all of these different variables such that you can just write them yourself. And so what you are going to end up with is you're going to be in a situation where you're not going to want to have to take all of these type of precautions, and you're going to want to use some other method in order to make this work and make it work better. And especially if you are working in doing software for a team or a group of teams, then you are going to need to learn to do this. Now, you may or may not think that this is really important to do. If I have examples in here of my code where I actually use simple string literals to look for stuff, you can see I've actually taken the precaution of doing dot lower here. By the way, this is some Quaka code that I just pulled up. So I've actually used this, and I've done that simply to not overload readers of the Quaka code with, what could be considered higher level programming techniques or patterns that you're going to want to use. But I think that it's important for you to at least be aware of this and to know what your alternatives are. So like if you don't want to have to continually type in capital J6.21.1 in every case, in every piece of your code where you want to use it, and if you decide to change it, you have to go to all of those pieces of code everywhere and change it. If you don't want to do that, there are some alternatives that are available to you in Python. So we're going to look at those. The first one that we're going to look at is just using constants. So if I was to use constants, what I could do is I could just say, okay, I'm going to set a constant. Now you'll notice that it's all caps. By convention rather than rule, we tend to put constants in software development in multiple languages in all capital letters. So this tells me, hey, if this is Cisco, it's going to be what I call a constant. Now, beware, in Python, is there anything such as a constant? And the answer is fundamentally no, that this thing called Cisco that I'm calling a constant, can somebody set Cisco equal to Fred later on somewhere? Yes, they could. So Python is not super strict in the way that it deals with things. It's meant to be easy and readable and understandable at a simpler level. And so you just need to be aware of not resetting the value of these things that we're calling constants. What I'm going to do is I'm going to come down here and I'm going to actually get rid of, or I'm going to comment out these lines. Now, you've seen me do this before just a moment ago. What I'm doing is I'm in PyCharm, I'm hitting Control /. And when I do that, it actually turns on the comments. You can see that each of these lines has a pound symbol or a hash mark in front of it. And when I hit it again, it uncomments it. So I'm going to comment that code out, and I'm going to uncomment this piece of the code that is for using constants. So let's take a look at what the code actually is. Now notice, and I think I can do it, up here I said choice. I used this string literal. I'm not using a string literal anymore. I'm using this constant called Cisco. Now, that means that this reference and this reference are guaranteed to be the same. This reference to Juniper and this one down here are guaranteed to be the same, etc. So you can see I've already protected myself from typos, and if you imagine it in your mind, if you make this a little broader, and this is not just within one module, but across a package or multiple developers, etc. Having constants for these things makes everything much easier. And if I was to come in here and like I did before, if I was to say, okay, I mistyped it, you can see I get a little red squiggly line and it doesn't know about CSCO. So there, Python, the actual portion that is evaluating this code in PyCharm, is looking at it and saying, oh, there's an error. In a like manner, if I was to have a misplaced small letter, you can see that it's going to say, oh, it doesn't know about that. Now that's kind of silly. It's the opposite of what I did before, but I'm just lazy and I didn't want to type capital C, small ISCO. So there we go. We have Cisco, Juniper, Arista. Let's give this a run and see if I did this correctly. Sure enough, I did it correctly. My vendor, remember my vendor is going to be Cisco, Juniper, or Arista. You'll notice that this will change at one point later on, but you can see here's my actual strings that it printed out with very little effort on my part, just setting these constants. I was able to use them later on. And you may be saying, well, that's great within the module, but can I do that across packages and stuff? If you are familiar with how we've done modules and packages, yes, you can. That would mean that another piece of code could import a set of constants and then use them in another module somewhere else for Cisco, Juniper, and Arista. So you could do that in much larger environments. Okay, so that is how you would use constants in order to overcome this literal issue. And in our case, it's just string literals. Okay, so the next method that we're going to look at to avoid using string literals is to use class variables. These class variables might also be referred to as static variables in other languages. The basic idea is this: we're going to declare a class called vendor, and within vendor, we're going to set 3 class variables. One is Cisco, one's Juniper, one's Arista. Now, if you're starting to freak out and saying, wait a minute, I don't know anything about object-oriented programming and all of that stuff, inheritance, encapsulation, all of the different business of how you do that, don't worry, this is not dealing with any of that. This is like super basic 101 of using a class, and it's not using any of the idea of instances of objects and stuff like that. So don't worry about that. This is just a nice, handy way to make our constants a little bit more specific. So let's suppose perhaps in your application you have other things that might want to have the name Cisco and want to be used there, not just the vendor name. Maybe Cisco in certain situations is considered a customer. You could also use this thing called Cisco, but if you wanted to differentiate them, then you could do what we're talking about here. And I say, or at least I infer for you, how we will end up using the actual reference to this data, this quote Cisco, close quote, this string called Cisco. And what we're going to be doing is we're going to be saying vendor.cisco. So you've probably seen dots used in Python before. Typically, it's in reference to the fact that the thing on the left is a class, and then the thing on the right is either a method or a variable within that class. And in our situation, we're going to reference the actual class name itself and then the actual variable within it. Now, once again, I've capitalized Cisco because we're treating it as a constant. It's just something that's going to sit there. Remember, there are no constants in Python. It's just convention that we capitalize them. And what you should do when you see them is make sure you don't modify them. Okay, so how does this look? Well, I've gone down to the code and I've commented out the portion that we did before. And here's my section where I say I'm using a class variable. And as I alluded to before, all I'm doing is I'm saying vendor.cisco, vendor.juniper, vendor.arista. Now, as you grow as a software developer, you will see this convention way more often. You'll see an actual class name and then a static variable or a constant or class variable, whatever you want to call it, within the definition of that class. So this is not uncommon at all. And in this situation, it's basically exactly the same as what we did up here. The only difference, remember, is that we've defined it within a class. So these constants are now class variables within the class called vendor, and we reference them by saying vendor dot whatever. And if I run this, then I see that it's working as it should again. And by the way, just as an aside, if you are Mr. or Ms. Eagle Eye and you're looking and you're saying, wait a minute, that date is different than it was before, my answer to you would be, well, yeah, I hope so. I'm randomizing all of my choices here. So let's just look at this. The first name is R10, capital UA 2.55, 10.0.0.3. If I run this again, you can see R6LF. Well, that's totally different. The version is different. The IP address is different. So every time I run it, I'm getting random numbers and stuff. So don't freak yourself out if you happen to notice that, hey, the things are a little bit different. That's as it's intended because I'm just generating random stuff for our testing purposes. Okay, so the next example I'm going to give on how you can avoid using string literals or numeric literals or whatever is to use enums. And enums are data types that are prevalent and present in other languages, and you use them in much the same way as we're going to use them in Python. There is not a specific thing that is an enum as a data type by itself in Python, but what you can do is you can create an object or a class, and you can derive your class from the enum class, and behavior will be similar to enums. And what you're going to see is that the usage is going to be very similar to what we've done up here with class situation, where we will be saying vendor, that's the name of the class, dot, and then whatever the name of the class variable happens to be. But enums are a little bit different, and I've kind of alluded to it right here. Enums have both a name and a value. And if you look here in this one line, what is the name of this particular enum? The name is Cisco, all in uppercase. What's the value? The value is 1. Now, there's a lot of uses for enums in many different areas of software development, and we're not going to go into all of these, but you can see if you peek ahead, I'm going to do 2 enum examples. In one situation, I'm setting a value to 1, 2, or 3, and not caring about what those actual values are. And in other situations, I'm actually going to set the string for the actual value for these things. So let's go look at the code and see how we reference the code for this. So here's my first enum situation, and I specify we're using enums, and we're going to specify the name. Now remember, going back up here to my enum, the name is the thing on the left and the value is the thing on the right. Clearly, I could care less about this value, so I'm going to be just using the name in this situation. Why would you use this? You might use it because you're trying to save space. It will actually only store a numeric value 1 instead of down here you can see it's storing an entire string. If that string was like 2,000 characters long and you cared about the amount of space that it was taking, maybe you're implementing something in a device with limited memory, then you might care about that. But I've done it, so let's go ahead and look at this. This is the name example. So we're going to, when we print this out and set the values here, here's what my choice is going to be. My choice is going to be vendor.cisco.name. I'm going to be referencing the name. And then when I set the value, it will be actually the name, which is, as we saw before, Cisco, Juniper, or Arista, and you'll notice that it's in capitals. And if I run it, as I've done before, you can see my vendor is all in caps. Remember before it was all in small letters. Now it's all in caps because it is printing out and using the name of this particular item in the enum. So that's the way that it is. Now, what would happen if I got rid of this .name portion and I just said vendor.cisco? Well, because this is an enum, this value right here is not just a simple numeric value. It's actually going to be an enum value, and things will break if I were to try to utilize that instead. So I need to dereference it, unless I care only about the enum. I need to dereference it by using .name or in the other situation, .value. So what I'm going to do, we've seen how that ran. Let me go up here and I'm going to comment this out. And I'm going to uncomment this. And I'm going to come down here and take this code that I'm using where I use .name. Remember, these all use .name. I'm going to not do that. This time I want to use .value. Let's see if I can uncomment this correctly. Let me run this and we'll see if I did it correctly. Looks like I did it correctly. You'll notice I'm using the value, and the value was Arista or Cisco or Juniper. You may be asking the question, well, what happened if you used this one up here where my value is 1, 2, or 3, and I left the code down there the same that's actually using the value. So now vendor.cisco is 1, vendor.juniper is 2, etc. When I were to run this, what would I end up with? Well, you can see that's what the actual value is. That's probably not what I want though, right? That's not what I want to have printed out there. If I'm not going to ask my boss to memorize Cisco is 1, Juniper is 2, Arista is 3. So I'm going to go back and I'm going to undo this, and we're going to let it run so that it makes a little bit more sense this time. And there's the value. So hopefully this makes sense. These are different ways that you can avoid using string literals, which in your small programs that you're using may or may not be an issue, but when you begin to put on a more important level of developing software, you're going to at least want to be aware of this. So make sure you have this in the back of your mind as you go forward in your journey to becoming a real software developer. So that's the end of this week's lesson. For the closing part, I normally just show you something, speed it up, and then we add music or whatever to it, and you can look at it or not. But this time I'm going to actually describe what I'm doing, because I'm going to show you something that you may or may not be aware of. There's this little menu bar with a bunch of reset pieces of functionality, and I kind of wanted to demonstrate to you exactly what it does. So that's what I'm going to do. Go through some of these. I will show you how changing the configuration can have an effect. You can change the configuration, then do a reset and observe it making the changes. So yeah, let's get started. Okay, so here I am typing in run Quaka to run the Quaka server, and you can see it starting, and down below you can see I'm running the user interface, and so that is going to start the user interface server. Takes a little while to get started up, so that's what it's doing right now. We have to wait a little bit while it loads all of the JavaScript code, etc., into the browser, and the browser gets things started and is running. You can see that we have the devices table set here, and you can see in the Quaka screen that we're beginning to do monitoring, etc. Here's the hosts that I've discovered. Here's the services that are actually getting monitored. Here's a list of events for this new running of Quaka. Now you can see that availability for this first one, the latest CSR sandbox, is unavailable. That's been unavailable for like a week. So what I'm going to do is I'm going to go into my configuration file, and I'm going to comment out that piece of configuration that is for that particular device. And then I'm going to say reset devices. And what this is going to do is it's going to go out to the Quaka server, and it is going to begin to shut down all of the services that are, all of the threads that are associated with devices and configuration. That actually takes a while because those threads tend to be doing a lot, and if they're waiting for responses, then you see changes not taking effect for a little while. So it's going out and doing that now. I'm refreshing it. You can see that we're beginning to do monitoring again. Now if I refresh devices, you can see that device is now gone. The one that I commented out, the latest sandbox, it's no longer in the list of devices. So that's good. I'm going to refresh the devices. It's going through. You can see the response time is kind of long. It's like 30 seconds to connect to the device via SSH and do stuff. Netconf is a little bit quicker. You can see that those have succeeded. Now I have these remote simulation devices that are configured in here. I'm highlighting the ones that exist in my configuration. I'm going to comment them out, and now I only have these 3 devices left in the list of devices that we're going to do. I'm going to do a reset again. Once again, we're going to see that termination is pending for both the device monitoring thread and for the configuration compliance thread. And so we're going to go out and do that. Now when we look at it again, we only have the 3 devices. We're not doing all, however many that was, 9 before. Once we get started getting responses back, remember the first one takes about 30 seconds to give us a response. There, it's finally given us a good response. Now I'm going on to the next devices, one using Netconf and the Nexus device using SSH. I'm going to eventually be getting ping responses back from those, so you should see those go green shortly. We're going to let it count down here, I think, all the way on its own, kind of organically, just so you can see that that works as well. There we go. All the devices are now happy and healthy, and I have a much cleaner list of devices than I did before. So now let's look at hosts. What's happening with hosts? Here you can see I have like 20 or so hosts that have been discovered since I started. Now hosts are not configured, but they are discovered as I mentioned. So I'm going to do reset hosts, and what this is going to do is it's going to shut down the host monitoring thread, and it's going to shut down the host discovery thread, and then it's going to start those all over. You can see it's beginning, and it's actually discovered a couple of devices. Maybe it hasn't actually discovered any yet. No, it's going through. The first one it discovers is 10 and 11. I'm going to come and refresh it. You can see that into the database, and now in our GUI you can see that we have discovered those. There's no data because when you do a reset it throws away all of the old data. So that is one of the things that it does. It kind of cleans up the database. You can see that we are beginning to get more of these devices populating our database and getting refreshed in the GUI. Now we're up to something like 8 different devices. If I look at the data, you can see that there really isn't any. There's 1 point there. There's 1 point of availability. If I go back and I look at the one that actually failed, you can see availability for that one is 0. Over time, we will end up with more data points as we do more monitoring and stuffing that status data into the status tables. If I go back now, you can see, okay, well, we're starting to get a couple of data points. I can see a couple of response times, etc. Now let's look at services. So services, like devices, are configured, and I have all of these configured, and we're looking at them right now. The one that I'm going to deal with, I'm showing you ESPN FC. That's one that I was playing around with yesterday. If I look at my services.yaml file, I can see there's my ESPN FC in the database. In the configuration, it will get put into the database. I'm going to change that to looking for the David Bombal website. So be careful of this. Notice the target is davidbombal.com for HTTP. You're going to see that again as data later on. So just make note of that. You may come back to this later. So I've made the change, and now I'm going to go and say reset services. Now services reset, because the services respond so quickly, they tend to repopulate pretty quick. So I've shut down the service monitoring thread, and pretty soon I'm going to be starting doing the service monitoring. Again, you can see that in the output of Quaka service. It's beginning doing the monitoring, and they're all pretty quick. You can see it's done David Bombal. When I go back to the GUI, you can see that, well, that's too long. I'm impatient. I want to look at that. And there you can see I'm doing HTTP to David Bombal. And you can see that we have a new piece of data for that. Now, something else that we might want to do is add a service. And so I'm going to come down here to DNS, and you can see here I'm doing DNS via Google. And notice I said the data is David Bombal. What that means is I'm going out to the DNS server and I'm looking for David Bombal. So I'm going to get rid of that so that you're not confused and just change that data to www.google.com. It could be any name that's out there, any host name that's out there that can be looked up in a domain name service. And so I'm just going to change that to Google right now. Now I'm going to add a new service that we're going to monitor. Google, as you may know, has a couple of DNS servers. Very important here, notice I'm changing the ID. I have 7 of them. These IDs are unique and they are the primary key in the database, so make sure that you don't mess with that and get it wrong and use the same ID as something else. You'll see errors getting thrown when we try to load it. So I'm going to just name that DNS via Google 2. Now I need to remember what is the name of Google's other domain name service. So I'm going out and I'm actually using Google to find their name services. And there is my name service 8.8.4.4. I'm going to come in and I'm going to modify that. Now I should have a new service. So I'm going to go back to Quaka. What do I have? 7 services here. I'm going to reset my services and we can see that it's starting already to do the services. That's good. If you have an eagle eye, you can see that there's already an extra one in the Quaka server output. Here in the GUI, you can see I have now my 2 DNS services. They're all looking at www.google.com, looking up that name service. For this last part, as I show you the status information for that device down there on the right, I'm going to be just kind of scrolling and clicking through the documentation that is available on the wiki. Now I'm showing you and clicking through a lot of the documentation that's available for Quaka specifically, but you should know that there's also a wiki and documentation available for the Python 52-week stuff. So enjoy.